Max Planck, the father of quantum physics. Max Planck (1858–1947) is widely regarded as the father of quantum physics for introducing the concept of energy quanta in 1900, which revolutionized physics by challenging classical theories and laying the foundation for quantum mechanics. His work marked the birth of a new era in understanding atomic and subatomic processes, earning him the Nobel Prize in Physics in 1918. Below is a concise biography highlighting his life, key contributions, and legacy. Early life and education: 1858–1879. Birth and family: born Marx Karl Ernst Ludwig Planck on April 23, 1858, in Kiel, Holstein, then part of Prussia, now Germany, into a scholarly family. His father, Julius Planck, was a law professor who later moved the family to Munich in 1867. Planck's upbringing emphasized intellectual rigor, ethics, and love for music and nature, influenced by his devout Protestant heritage. Education: a bright but unremarkable student, Planck attended the Maximilian Gymnasium in Munich, where a teacher sparked his interest in physics and mathematics. He entered the University of Munich in 1874, studying under physicists like Philipp von Joly, who advised against physics as everything is already discovered and undeterred. Planck spent a year at the University of Berlin in 1877–1878, immersing himself in thermodynamics and electromagnetism. He earned his PhD from Munich in 1879 at age 21 with a thesis on the second law of thermodynamics. Career and key contributions: 1888, 1888, 1900. Early positions: after a brief stint as a lecturer in Munich, Planck became an associate professor at the University of Kiel in 1885, focusing on thermodynamics. In 1889, he succeeded Gustav Kirchhoff as full professor at the University of Berlin, a post he held until 1926. There, he mentored future luminaries like Albert Einstein, through not directly and contributed to entropy and heat radiation theories. The quantum breakthrough, 1800s, struggling with the ultraviolet catastrophe, a failure of classical physics to explain black body radiation. Planck derived a formula in October 1900 that matched experimental data. To resolve it, he reintroduced the idea of energy quanta. Energy is emitted or absorbed in discrete packets, quanta, proportional to frequency, presented to the German Physical Society on December 14, 1900. This Planck postulate was initially seen as a mathematical trick, not a physical reality, even by Planck himself. Einstein later applied it to the photoelectric effect in 1905, solidifying quanta as real particles, photons. Quanta, photons. Later years and personal challenges: 1909, 1901, 1947. Recognition and influence: Planck's quantum hypothesis gained traction through Bohr's 1913 atomic model and others' work, earning him the Nobel in 1918. He became president of the Kaiser Wilhelm Society in 1912, promoting German science amid World War I. A staunch patriot, he advised Kaiser Wilhelm II but opposed Nazi extremism. Tragedies: Planck endured profound losses. His daughter and son died in childbirth. Another son was executed for alleged involvement in the plot of blah, blah. Legacy: Planck's quanta concept birthed quantum mechanics, influencing Einstein, Bohr, Heisenberg, and Schrödinger, and enabling technologies like semiconductors, lasers, and quantum computing. The Max Planck Society honors him with over 80 research institutes. As he reflected, a new scientific truth does not triumph by convincing its opponents, but rather because its opponents eventually die, and a new generation grows up that is familiar with it. While Einstein and others build on his ideas, Planck's reluctant revolution remains in the field's origin story. Hmm, interesting, interesting.